In this video series, we're going to build up a Python application for data processing and data visualization, as well as plotting general functions. So, for example, the first one is plotting a given function of x. That here is the normal distribution, but also you can derive the derivative of the function or integral, and you can write get the graph numerically, or get it in the symbolic expressions. So, for example, if you give another function, sine of say x to the power of 2 divided by 10, you get another graph. But also you can say define your function, the relation between x and y in a general fx and y equals 0, and by that you got the plot as well as the solution of y as a function of x. But mostly our aim is for data visualization and data processing. So, for example, you can load a given set of data. Here is the list of movies over the years, and for example, you can plot the features of say the year of release and the budget, and demonstrate the curve or variation of budget on different years. So, for example, this is the movie budgets on different years for all different countries. If you want just, for example, in the US, you can choose to say just consider only US and plot data, and that's this value that in each year the mean we considered mean for the budget, and the mean in the US is bigger than the mean in general in the world. But also you can choose the scatter graph, plot them, or you can get in each year the sum of say budget that you that has been spent on movies. So different visualization. Also, you can prune your data, for example, removing missing data. That here a lot of movies has budget 0, that means it's missing data. So we can say remove the budget zeros, not equal to 0. And if we have that mean, we see that we have a different curve if we not using this this missing data statement. So we can work out with the data and visualize it, but we can also do machine learning methods to do prediction. For example, first we can find out the regression line between different features, continuous versus continuous features. For example, if you want the relation between budget and revenue, you can derive the regression line between these two by just simply putting from the features from the column list of your data into these labels. And you can, for example, prune your data, saying only consider specific feature, or ignore this set of features. So by that, you now have this a small set of features that if you have a regression line, it would be a different well. And also you can this regression line is the intersection of your plane, because you have many columns, and so it's in general a high dimensional space. and that you only consider two of those features. Therefore, what about the value of other features? So in general, when we draw that, we consider to be the average value, but we can define a different value. For example, the average of popularity was 3.6. Say if we want to have only consider movies with high popularity of 50 or 100, then we would have a different regression line, and you have the regression line in here. So it shows that now for higher popularity movies, you have a higher revenue compared to low popularity. Also, we can do classification with different models of classifiers like naive Bayes, decision tree, logistic regression, support vector machine, or k-nearest neighbor. And again, for this a set of data, we can find out for a categorical feature like rate category that the users given to the movies, the rating of the movies based on the budget that is spent on the movie. Is there a relation that we can visualize? Yes, there is. So for lower budget movie, the expectation is that the rating would be low, and as you go up in the budget, the classification of the prediction rating for the movie would be higher. So that's the naive Bayes. You could use many other type of other classifiers. And also, what about if you want to see only in 2000? Is there any difference? No, it's not so much, a little bit. And you can manipulate the data by moving around or by zooming on it. So, for example, seeing if there is any difference, you can packet all these features and all this data processing in one application and install it on Windows. And by just running it from Windows, use this directly from Windows. So let's start building up this application in Python. And obviously, there are two aspects for this application. One is the GUI, the graphical user interface, that we need to build up and to make it easy to work with the more complex data analysis and data modeling. First, I'm going to show you what would be if we use and this GUI, the graphic user interface that we have built, and just import it. And in just with 3 lines, we can build up a window and see the capability of this GUI and that we gonna build up in the next video. So let's from GUI final that I've already built, import all, and we need to have just one line to make the application started. That this function is defined on the GUI, and it returns these values that the app is the actual application or the window that we have to start its main loop to actually start the windows. So by just this 3 line, we see that we can generate the window, but doesn't have anything inside except the matplotlib figure and the toolbar, but below is empty right now because we don't have any tab inside it. We have to create tabs inside this area, and that's just by defining. So let's call tab 1 equal tab frame. That's the class that we have defined, and for that we need a set of parameter to pass. First is the notebook, that is actually the area under the toolbar that we had in here. So this is the notebook that we have to pass it as the root for this tab, like the name of the tab. So for example, we can say this should be tab 1, and we need to pass the list of the names that we wanted to put on or widgets in the tab, call it widget names, and the configuration for each widget. That means what functionality should be associated with that button or text widgets. So we put all in a dictionary called, say, config, and say we want to have two options, option 1 and option 2. So we need to define these variables as button 1, button 2, button 3. So these are the name of the buttons that we gonna use. This would be button 1, 2, 3, 4, and we have 4 text widgets that we defined. And for configuration, we say, for example, button 1 command should run function 1. So we need to define function 1, define func 1, and for now, let's pass. But we need 4 of them. Create 4 of them, and that's done. And if we run it, we have the notebook having one tab inside it. So now we created a tab, but just 3 lines. But we have to put functionality to this button. Right now, it doesn't do anything, and that's the option 1, option 2 that we passed in. And the name of the widgets appearing on the bottoms or inside the text values. And also these text, the first 2 text pictures would the value would disappear as soon as a click is done on that widget. So let's build up some functionality. For example, let's put button 1 to print the value that appears in the text anytime, and that would be like simple as just first bringing the values of these text widget to our function, and saying that read widgets, that is a functionality again defined in this GUI final that we're going to build together, and that doesn't need any input, but the return value would be all the text features, T1, say, T2, T3, T4, and the choice. And now we want to print it. And we can say print all these values. And if we run it, we have this functionality that the bottom 1 now can print anything that appears in the features. So new in the first one, and this value. And if we change the option, now let's print the new values that has option 2. Let's do another functionality that we need, and that's for plotting. So say function 2, we want to be a plot. So the next button, say call it plot, and the function 2 would be is associated with B2, therefore it can do plotting. Let's, for example, and we can do the plotting with just 2 lines. The access that we return when we build the app, we use that and say plot or scatter, and all we need is an X list and a Y list. Say X list is 2, 4, 5, 8, and the Y list is say 3, 1, 6, 2. So if we just we also need to say canvas draw. So just by these 2 lines, we will be able to change our application to be able to do the plotting. So now this bottom name is plot, and if we does the plotting, we can choose, for example, a scattering, and we can define based on this option. For example, we can here do different plots based on the option. And so we need again to have these values of the choice to be read. So we could say we need choice. You could, for example, just say if you didn't need the other variables, so we need to return the choice, and based on the choice decide what sort of plot we want. So if, for example, choice is say scatter, we want to do a scatter plot instead of plot, a scattering. And obviously we need to have this option for the user to select. So say option 1 is scatter and option 2 is plot, and therefore if it's not a scatter, else do the plotting. And therefore now we can change the sort of plot based on the selection. If it is a scatter and we do plotting, plotting, it would be a scatter plot. But if we choose plot, it would connect the dots as well. Another feature that we need is be able to manipulate or change or update a dictionary. Say we have a dictionary, call it diction, and say you have keywords like apple, be say 3, and orange be say 5, and say grade be 9, and we want to manipulate this data. So say we want the third button to be an update button, and by in that third function, therefore we can just take this dictionary to a function that we developed again in this GUI final that called update dictionary, and the dictionary is diction, but because it's outside this function, we have to call it as global diction. And if we run it, now the third button is an update button that it shows the values of the dictionary when we print in a new window, and we can update, for example, to be 3, say 1, and this would change the content, we can say that the value is changed now, but if you want to make sure, we can put that in the print every time in the print command that also shows the values. So that would be another feature that would be very helpful in our application that we need. Besides these main features, the main aspect is to be able to add any number of tabs that we want. That we can do by just creating another tab frame by calling this function and passing the widget names and configuration that we want for our new tabs. So say we can change every of those values for our tab 2 and call it tab 2, and the function associated with each button could be the same or could be different. So we can have, for example, for the last one, and to have a function, say 5, and for, say, the update or the print button. So we can say for print of tab 2, use function 5. So in that case, if we run, we now have 2 tabs. By just adding this 3 line, every 3 line, we can make a new tab 2, and the print now would run the print of function 5 that we haven't defined yet. But for tab 1, the print was the original one. So let's say, for example, for tab 2, the print be that also we printing the dictionary values that we update. Or we could have used the same function and pass the parameter that I'm gonna explain next. For this, obviously, if we wanted to print also dictionary, we have to bring it as a global variable and also print that diction. So that's one way, but it's not good in code usability. We may have 100 line of code in here that we could use again. So we could use actually the same function, but pass parameter to define which part of the code to be run in every case. So now, for example, by this change, we see that the tab 1 only prints the text value, but tab 2 also prints the dictionary. And if we can change, if we change the dictionary values, and the dictionary will be updated. So, as I said, for code usability, we may want to have in the same function, but by passing a parameter. So we can say pass a parameter of choice, or to print or not print the dictionary, and we can say if this choice value is true, also print dictionary. So we need to pass this argument. So how do we define the function 1 now? So if instead of function 5, we want to use function 1 in here. So now function 1 needs a parameter. In that case, we define it as a lambda function, and say it has no, to run this function 1 with parameter of, say, for tab 1 false, but for tab 2 to be true. And that would make the same function. So print here doesn't print, but print here prints that one as well. So these are the features that we're going to build up in our GUI. Let's start with building up this GUI from scratch. First, we build this GUI based on the tkinter. So we need to import these libraries of tkinter as well as matplot for graph or plot figures. And also we need system for printing. So first thing that we said that, okay, we need to import from GUI, import everything. And what we need first to build up the application was to just have this line of making an app that currently is not there. And then at the end, we have to run the loop, main loop. So let's build up this make app first in the GUI. That has to be exactly with the same name, define function of make app, doesn't need any input. First, we need to use the custom tkinter to make windows that are of new looks, not old-fashioned look. So let's set appearance to be the same as system, and also the color theme, custom tkinter, set default color theme to be say blue, and equal custom tkinter tk custom tk, and that's it. It creates the app window. Now we can define that we needed to pass as the return value of this make app geometry, as 720 by 900 would be the size that is suitable. And also we have to add the title, say we call it data processing as the title of the application. And now we ready to make the figure plot at the top of our app. And so first we use matplot of figure and x to be the matplot plot, because we imported matplot as plt. So but using subplots that would generate a figure and an axis, and that would be again the returning value of this function. But also we need a canvas, that is the area that is plotting is done in that area, in that frame, equal to be say figure canvas. That one would make the frame for a metal figure, and we pass the parameter figure and say the master is the app. So app is actually the window, the whole window, and we're saying that this is one of the elements in that window, this canvas. And we also needed a parameter figure text that we use in writing LaTeX formulas on the figure, and that for now let's pass it as none, but we get back when we and change it to when we needed this. So also now we have to pack this canvas. So any frame that we create in the app, we have to pack it. So we should say canvas dot pack, but for this sort of frame that are coming from figure matplotlib, you need to say get the widget. So get tk widget, and then pack. That would put the canvas inside the app as the first element. So the figure would be always on the top, but we need other windows to pack as well. The next one is a toolbar. Say the name is toolbar equal, and that's navigation toolbar, and it's inside the canvas. It's related to canvas, but inside the app, and the pack tool bar equal false. So by this, we generated a toolbar, and we have to say toolbar update would connect the toolbar to the figure, but also we need to generate the notebook that is the frame that is under the toolbar in our application. So the whole frame under the toolbar would be a notebook that contains the tabs that we're going to build up later. So first we must have a notebook as a TTK of notebooks, and the parent is at the same window, but in the order of the third element in this window that we are now packing. And notebook and pack would put it below the toolbar, and for that we should put that this notebook fill every space that is remaining in the window. So we say fill equal both and extend equals true. Expand equal true. We also need to bind this notebook to an event, to a function that whenever the user changes the tab, we run that function. So we're gonna bind this notebook with the event and the function. So the event would be the notebook tab changer. So whenever the event of tab change happens on this widget, we have this event that we want to run, say on tab change function or tab selected. But right now we don't have it, so we need somewhere to define this function. Define on tab, and for now let's pass it. And we're almost done. We can return just the whole set of returning values. So return all of those values. By this, we have generated the GUI that is able to just create the windows with the toolbar. So if we save this and run this application with just 3 lines, and that gives us this error because we didn't put when we wanted to get widget, it has to be as a function. And if you save it and run it again, it gives us the app with the matplotlib figure at the top, the toolbar, and then the notebook in the down section that we can pack any number of tabs inside it. We may move this toolbar to the left by just saying that when we pack the toolbar, anchor rest and fill TK X, and with that we can move the toolbar to the left. Now we need to add the capability to create tabs inside the notebook in the area below the toolbar, and just by adding a few number of lines, create different tabs. And the tab, the class is tab frame. So let's create a class of tab frame that obviously have initially the constructor. First we have to define, and in that function, because when we create these objects, we need a few parameters. First is the notebook, so we have to pass notebook as well as the title and three other parameters, and the names and the configuration, and as well as the choices. So first of all, we create an internal or object attribute choices and put it as, because we want it to be an object attribute, call it self. We have to call it self choices equal the choices that we bring it from here. So that's easy part. But now we have to create the frame that holds the tab content. So call that frame the root frame, and that would be a TTK frame. And the parent of that is the notebook that we brought it. So we needed that notebook to create as the frame for that. Now we have to add this notebook to the root and to the frame that we created, and with the title of text being title that we brought it again. As you see, we needed first this text widget that inside the frame root that we generated. So we need to create a text widget and call it self text widget, to be a entry, sorry, text of TK. But the parent of this text would be the root frame, and height and width should be 10 and 90 to fit that size of the window that we created. And we need also 2 frames, and that's the reason for 2 frame. So we need another frame to put under this text to hold these 5 objects, but another frame here to put in this order, because we are going to use grid, and the number of columns are different, we have to generate two frames, one frame for the top part and one frame for the bottom part, the whole two rows. Call it first frame to be just TK frame, and the root is the parent of that again, like the text widget, and also another one as the second frame. And the order that we want to pack these things inside our app is first the text we have to pack, and then the first frame and the second frame. So we should say self text frame, text widget, pack first, so it would appear on top, pack, and the second frame. So with this order, we want to put this frame inside our root frame, and that itself is inside the notebook. And now we have to create object that we needed for these two frames. That was the bottom ones. So they would be also object attributes. Call it B1 to be a custom take inter CTK button. Yep. And the first button was in the first frame, and the value that we want to appear on that would be the string that is the first element in this widget name. So we could say text equal the widget names, widget names of element 0, and the configuration or the association with the functions is the command that we need to pass. What would be the command? Whatever is in configuration dictionary that we brought in, associated with the key of B1 command. So that would make the first button. We need 4 of them, 2, 3, 4, and we can change 2, 3, 4. Now we built our button object, but also we need 4 text object. So first one, call it tiny text 1 as another object attribute. Again, custom enter. At this time, we need CTK entry. So these are entry objects. The first one was in, and also we should notice that the last button was in a different frame. So the first 3 was in the first frame, that the last button should be in the second frame. So we should change this to second one. And for this 2 first tiny should be in the first frame. And the width of that should be small, 100, and height of 30 pixel. And that will be generating the first text object 2, 3, 4, and the second one again is in the first frame, but call this big ones as BT1, and big text T2, and these ones would be in the second frame. So we're done with the text, but we also had labels, these labels object. So we have two labels to create. We have to call it, say, L1 to be just custom TK enter objects of CTK label. And they would be in the second frame. So for both of them should be, and the label text that we want to appear on that label should be the value that we get from the widget names. Object number 3 would be that, and for the second label we would have object number 4, self option menu, and that would be a TK object of option menu. But for that object, we need to define a string variable in TK and connect the option selected to that string variable. So we define a self selected choice, call it, equal to TK of a string variable, and use it in here. So first of all, the parent of this menu should be second frame, and the text associated with that we read from would be self selected choices or selected choice. But what is the list of choices? The list of choices is the choice that we have, but we already put in the self choices. But because this is a vector or list, we have to put this. But also we want to first always start with the first choice. So let's put the value self selected choices set to be the first value of that. And choices of 0, and that we had in the list of choices. So now let's pack this by putting in order. So if we pack, it would be vertically packed, but we want to be horizontal, so we have to use grid for each of them to put it in the frame, in the corresponding frame. And self for B1, for example, we use grid, and that would be the first element. So it would be row equals 0 and column equals 0. And let's put a padding of x equal, say, 10, and a padding of y of also 10 to make space between them. And that would make the B1 to be the first element. For B2 and B3, and we need also to pack the next element, that is TT1 was So grid, and that would be for first step. So the row would be 0 and the column would be 1. So we move in horizontally, and again the same padding. So we use this padding for creating a space, and for text 2 is just the next one. So we put it as column 2, but for B2 we had so we can just copy this here and put as B2 for column 3 and B3 as well. As column 4. So that makes the arrangement for the first frame. For the second frame, let's put it in here as again, and the first thing would be the label 1, and we would use grid with row equals 0 and column equals 0, because they are now in a second frame, and the padding again of 10 and pad y of say 10 again. So that would be the first element. 2, 3, 4. The next one was big text one. That should be appearing in column 1, and the select menu, this option menu should be the widget that we put as the third element. So second, and for the next column we have almost the same thing. Sorry, for the next row, but it would be L2, and the row would be number 1 instead of number 0. Because we have, this is the second row that we are building up, and that would be L2, PT2, and instead of option menu we would have the B4, and therefore now we have the list, but the problem is the text, the width. We didn't put bigger text, so actually this should be 350 instead of 100. But also let's add the name of the text widget inside the widget. So for now, it doesn't show anything in that. For that, we say that for TT1, insert at 0, the widget name of element 5 would be for that, and 2, 3, 4 for text 2, number 6, and for text, big text 1 and big text 2, number 7 and 8. And now the text appears as well, and the widget is longer, and we have the option selector. So the next step is to be able to print and use that text part for printing. Right now we don't have this capability. For that, we need to create a class of printers to redirect any print command that we use that is usually goes to the STD output system. We want to bring it to this class of printer. To be just taking the text widget and that we have in the tab object. So we have to pass the text widget that we want that printer print to that, and we put it as a object attribute. So self text widget would be the thing that we bring it here. That's it for the create and for the constructor. But what we need for this printer function is to define a write function. We bring the text and we want to write it. How do we write it? We get the text widget and we insert whatever is the text, but up to the end we have to say tk end and the text that is brought here. So also we need to say C to scroll down to the end. So that's it. By this, we can connect a text widget to receive any print command. But for that, we need to somehow create a printer object and connect it to the STD out of the system. So that would be, depending on which tab is selected, we need to have different widget corresponding to the selected tab. So that would be inside the on tab selected function that we needed to define. So let's bring that here. And somehow in here we have to say std system std out should be one printer object. But let's we can't complete it right now. We have to see what text widget we must have the index or reference to the tab. We don't have yet. How do we get the index to the tab? We can have the when the user select a tab, we can get the index of the tab selected, but not reference to this tab itself, to the tab frame. For the index, we can find out tab ID by just because this function actually brings an event to be event then widget then index. So that, and if you say current as the parameter, it would find out what index has been selected. But this is not what we need. We need a for printer object, we need the text widget. How do we get that text widget? So we need to create another class and that call it tab collector. So for every tab that we create, we add the reference to that tab to the list in this tab collector. So call it class tab collector, and we put as a class attribute, not an object attribute. So it would be acting like a global variable. Anytime that we call the tab collector tabs, it would reference this anywhere inside our actual function or in here. So at the start of the program, this would be empty, but we define the constructor and to be taking the tab that make an object of this. So we go to that definition of our tab frame, and every time that one of these tab is created, we create an object of tab collector. And we pass the tab that is created, that is the self. So self will be the tab that would call this function of initiator, and that tab would come in here. So we now have access to the reference to the tab. We put that inside the tabs. So in the constructor, we can say that the class variable that we have to therefore call the class name for that tabs should be appended this tab. And so by that, we every tab that is created, the reference would be in here. But still, how do we get the tab reference in here? And say tabs of ID, tab ID. But tabs is a class variable. So that would create a printer with that tab, but this tab itself doesn't need to be passing. The text widget of that tab should be passed. So we should say text widget. In this way, we created a printer with a text widget and connected to the output of the standard output of the system. So any print command now goes to this text widget. And depending on which tab is selected, we would printing on the corresponding text widget of that tab. That's it. Every time that someone choose a different tab, we're creating a new printer. So this should actually be once for every tab. We should have one object printer. Otherwise, we don't use efficiently the memory. So the better way is to create another list in this called printers to be just empty at the start. But every time that we create one tab, then we create actually a printer in there. So we just create again tab collector, printers, append a printer that we generate by with the tab. of text widget. So tab would be the tab that is created, and we take the reference to its text widget and make a printer and put it in the printers list or collections. Now, every time that the user selected this tab, depending on where which ID, which tab is selected, we go to the list of printers and choose that printer. So we just, instead of this, we can just remove and directly use the printers that we create, the printer that is created already and is in the collections. We can also use this tab collector and reference a tab. For example, if we want to see what is the current tab, so we must have also another variable, class variable, call it tab ID or current tab ID, that at the start is 0, but anytime that someone selects this, we would update that to the ID that is selected, tab ID. But this is tab collector class variable. So every time that we want to see what tab we are currently in and access the object corresponding to that current tab, we can say tab collectors, the current tab ID. That would be the tab ID corresponding to current tab, but that would be the index. So if we want the actual tab, we should go to the actual list of tabs and say tab collector and tabs. That expression would always reference or points to the tab that is currently active, and we can read, for example, the values of objects. Anytime in our package, we can use that argument to get access to the current tab. So, for example, we can use this expression to write our function for read widgets. That was one of the capability that we were looking for. So define read widget function, and at the start we get the tab that currently we are in, and now we can reference elements of the tabs. For example, tab tt1 would be the text1 value. So if we call the method get, we get the text value of that, put it, say, in the t1, and we can create for any other one, t2, say, to be tab text, tiny text2, t3 to be big text1, and t4 be big text2. But also we want the choice, so call it choice equal to tab was selected choice, a string variable of tk. So we use the get command to get that value. Now we can return all of these variables, T1, T2, T3, T4, and the choice, and now be able to access and print. So let's try by just putting in the first function, print read widget, and that's it. So it would be able to make this function 1 as a print function and call it print. And let's try. We should say capital N. And the print prints the value of the text, and if we change it to something else or change the option, it is working. So let's add the other feature that we wanted to. When we click it, the text will disappear, and that would be adding this 2-line for these two text features, that whenever we click them, whenever the event of focus in happens, we run this function that is deleting the content, making the content disappear. We may also want to have the capability that if one of these tab enters data and enters, upon entering, we run a function. To have this capability to be added as a extra option, so we can have our configuration dictionary to have a keyword like say big text 1 bind to be function 1. So whenever we enter in that text, we press the enter key, the function 1 to be run. To have this capability as well that we needed, so we can have another binding for the event of return. To that, we say self, for example, TT1 object bind, but we are not sure that always this exists. So we have to say if the say keyword of TT1 bind exists in the configuration dictionary in config, then bind the TT1 event of return to that function that is in config with the keyword of that TT1 bind. And we can have it for all the text objects. So if there is a T2 bind or big T1 or big T2, you should have place so let's try to see if this functionality now exists with this extra keyword. So whenever I finish my line and say new and enter, this should be printing because it takes the event as a one argument. So we have to define it differently for events we call it lambda function that has an event as the input, but as the output we want to run just the function without the event. So just fun1, but don't pass the event. So with this we make sure that we don't passing any argument of what to function1. Let's try this one. And if we enter, it would print. So, and that finished the GUI with the capability that we wanted, except the two capability that we deferred it to after doing some algorithmic or data processing work on this. And in the first place, in the first part, we don't need these two, that is, or tab or window doesn't have a help, and also it doesn't have the capability to manipulate a dictionary, and that would be needed more later for more advanced data processing. Thank you for watching.